What is up, party people? I'm still sick. Okay, so now we're on the 2.3. So you should be watching this on Thursday. Okay, good. You can still see that. So, I've kind of talked about this last time. But when we're talking about making linear models, we can easily identify a linear model, but I like to call, there's lots of different ways of writing it. And I don't usually like to call B, the initial value. I like to call it the y-intercept, right? So if we're talking about slope-intercept form and point-slope form, we need to define what an intercept is first. So the y-intercept is the y value for when x equals 0. This is a point on the on the y-axis. So it's when the line intercepts the y-axis. All right. So here's my axis. There's my line. This is the y-axis, right? So it intercepts it right there, intersects it right there. So that's the y-intercept. And that's when x equals 0. Okay, so we have 3 different ways to write in equations. I've only listed 2, and then we'll talk about the third one later on. So just know that there's 3, and it's kind of similar if I ask you to solve a quadratic using the complete the square method and you do it differently. If I ask for you to give me a slope, an equation for a line in a certain form, it's going to be incorrect if it's not in the right form. Okay, so read the instructions. Okay. So the first one is probably the most common. It's my favorite. It's the slope intercept form. And these first 2 forms can tell you what you need to make your line, the thing for your line. So slope intercept form. We're not using f of x, we're going to use y now. So I think we're all pretty used to this one. So y equals mx plus b, and it's called slope intercept because m is our slope and b is the y-intercept. So I use my slope, my intercept, and I make a line out of it, an equation for a line out of it. Okay, the next one is point slope. This one's really nice if you just are given points on a line. All you need to see is, because you can find the slope, oh golly, between 2 points, and then just use one of them, smack it in this form, and you got an equation for a line. So point slope form is y minus y1 equals m times x minus 1, where m is the slope and the line passes through x1 and y1. Okay? Ooh, and it has to be in these specific forms to be called that form. So we'll go see that in a few examples. All right, so in general, point slope is the easiest form to acquire. Again, you just need 2 points, and you just plug it in. You don't have to move things around and find things. All right, so finding an equation for a line with the slope 3 and has intercept 2. If I'm not given a specific one, it's up to your own discretion, right? So if I'm given slope and I'm given intercept, why not use slope intercept form? Makes sense, right? So slope is 3, intercept is -2, so y would equal 3x minus 2. All right? You don't need to do plus -2 just to keep the plus part. That's more than okay, right? I can also be given the equation of a line and asked to make it look like slope intercept form. All right, so remember, slope intercept is y equals mx plus b, something times x plus just another number. But most importantly, I need y equals. So let's do that first. So I have 3y minus 2x equal to 1. So let's add 2x onto both sides, plus 2x. I have 3y equals 2x plus 1. Divide each side by 3. And I get y equals 2x plus 1 over 3. Is this slope-intercept form. No. It's at mx plus b, not mx plus b over c. So I just need to pull my fraction apart. So that way I just write 2 over 3x plus 1 over 3. So just got to be really careful with that, okay? So sorry about the sniffles. All right, so, oh golly. Okay, so sorry. Whew. Something times x plus something, okay? Not something times x plus something divided by another something, okay? So we really need to make sure you're careful with that form. Definitions are very important in mathematics. Alrighty, so now we're asked to find, next example says to find an equation of the line through 1, 3 with slope -1/2. Well, great. I have a slope, I have a point. I would use point slope form. So that says it might be easy to write like, oh, x1 is 1, y1 is 3, and m is -1/2. Kind of lay it out like that. Point slope form is y minus y1 equals m, x minus x1. And I'm not going to distribute that. The reason is because it's clear what's the point and what's the slope. So if you distribute m, it's not that clear what the point is anymore, okay? Whew. So y minus 3 equals -1/2 x minus 1. And I'm just going to write don't distribute. Okay. Alrighty. Oops. I think I wrote something wrong. 1 second. Oh, no, I just wrote my thing wrong. We're fine. Okay. So what if we aren't given a slope? I've kind of already said this already. I spoiled it. We're just going to find the slope and choose whatever point you want. All right. So first, find the slope. So remember that m is going to be change in y over change in x. So we can kind of call it this if we want, which is going to be -4 minus 2 over 3 minus -1, which is going to be -6 over 3 plus 1, which is -6 over 4, which is -3 over 2. And now it doesn't matter which point we choose. So I can say either y minus -1 equal to -3/2 over x minus 2, which would be y plus 1. Or we could have chosen the other point, which was y minus 3. No. Oops, I did that wrong. What did I do wrong? I got my x and my y mixed up. That's why it's good to write them out. So it'd be y minus 2x minus -1. For everyone at home that caught that, good job. I also could have done it with this point. So I could have done y minus -4, -3/2, x minus 3, which would have been y plus 4. Ooh. So those are the same line. You just need to give 1 in your answer, okay? So, but that's the glory about it. Alrighty, so let's work on to more applied problems. Woohoo! I think this is, oh God, it's a multi-porter, and then we're gonna talk about vertical and horizontal lines. Okay, we're not quite done yet. So, a vending machine operator services the soda pop machines. So funny, soda pop in a freeway. God, where are these people from writing soda pop in freeway? He finds the number of cans of soda he sells each week depends linearly. So it's already telling me it's a linear equation. On the price that he charges. At the price of $1 per can of soda, he sells 600 cans. But for every 25-cent increase in the price, he sells 75 fewer cans each week. Already. So we need to hold on. Sorry. Need to blow my nose a lot. So something that we need to kind of choose right now, if we're going to talk about price in dollars or price in cents, I think we should just keep it in dollars. So rather than cents, just we'll see. So at $1, he sells 600 cans. So that can tells me that one of the points on the line is 600. And for every 25-cent increase in the price, he sells 75 fewer cans. So at $1.25, he would sell 75 less cans each week. So it'd be like 600 minus 75, which is 525. All right. So I'm given this one, and I found this point from the 25-cent increase that he sells that fewer cans. So fewer, I'm decreasing. All right. We're creating like a demand graph, basically. As price increases, people are like, oh, I don't think I really need a pop for that much. So those are my 2 points. Okay. So now with 2 points, we know that we can find a line with that. And you can model it point slope, slope intercept, whichever one you want. So for both of those, we need slope. So let's find that. Okay. So our slope is going to be 525 minus 600 over 125 minus 1, or 1.25, right? $1.25. So 525 minus 600 is minus 75 over 0.25. And we were actually kind of told the slope in a really obscure way, right? It says for every 25-cent increase, so for every change in X, oopsies. So this was delta X. He sells 75 fewer. So that was delta Y. So that's going to give me, I think it's going to be minus 100. 75 by 25. Oh, 300. So negative 300. I don't need units, right? I'm just creating a line right now. So I'm just building up each piece. And then I can plug in whatever point I want to. All right, let's just go with this one. That one looks pretty nice. So y minus 600 equals negative 300 x minus 1. Okay? I just plugged in a point. Pretty cool, right? So we're going to keep using that equation, moving it down in these next examples. So how many cans of soda will he sell if he charges 60 cents per can? So 60 cents per can implies that X would equal what amount? 60 or 0.6? Remember, we kind of had to make a decision earlier that we kept price in dollars rather than cents. So that's going to be 0.60, kind of making it clear that 60 cents. So that would be y minus, what was it, 600 equals negative 300. X right now is 0.6, so 0.6 minus 1. So that's going to equal y minus 600. 0.6 minus 1 is negative 0.4 times negative 300. Give me 120, so plus 600. Point slope is easy to find. Not point slope. Yeah, point slope is easy to find, but it's kind of hard to solve for things when it's there, because you gotta always move something around. So y would equal 720 cans. And we need to put units here because it says how many cans. Okay. So if he charges, so $2 would just be X equals 2. Okay. So $2 implies X equals 2. So y minus 600 equals negative 300. 2 minus 1 will give me y minus 600 equals 2 minus 1 is just 1. So this is minus 300 plus 600. So y equals 300 cans. And that, if you kind of think about it a little bit, when prices go up, a lot more people will be like, I actually don't think I need that, and will forego buying a can of soda. If I see a 60 cents can of soda and I was like, wasn't even thinking about soda, I'd be like, it's 60 cents though. Like, what if I liked it? I'll get it. But if it's $2, I'm like, ooh, it's kind of expensive. I can buy a liter for 99 cents. What do I need a can for? For $2. And we can see that it's going to be a decrease too because of that negative slope. So that's also an indicator of a smaller value in X is going to give me a larger value in Y. Okay. So find the slope of the line. What does the slope represent? So we found earlier that M equals negative 300. And what does this represent? So we can kind of say it like how we talked about the 25-cent increase cost is 75, decrease can decrease in selling. So then minus 300, we can say every increase let's do every $1 because it's basically negative 300 over 1. So every $1 increase results in 300 fewer cans being sold. All right. Or we can say just for every dollar increase or something like that. If I increase the price $1, cans will decrease 300. All right. Now we're asked to find the y-intercept of the line. So the y-intercept we learned earlier. It occurs when X equals 0. So I'm going to take y minus 600 equals negative 300 x minus 1 and plug in 0 for x. 1 second. So sorry. Okay, so y minus 600 is going to equal negative 300 times negative 1, 0 minus 1. So that's going to be 300, so plus 600, plus 600. So y would equal 900. So remember, x here is our price. So when we're talking about what does this represent, we say when we sell cans for $0 or free money, we will sell 900 cans. Okay, I hope that makes sense. Just kind of remembering what your input is. It's money, it's price, it's dollars. And then my output is cans. So we just kind of mix it in with some words. Alrighty. So find the x-intercept. All right, so if the y-intercept occurs when x equals 0, the x-intercept will occur when y equals 0. Okay, so I'm going to do 0 minus 600 equals negative 300, x minus 1, and then, so this is negative 600. I need to get x by itself, so I need to divide each side by negative 300. So what is that going to be? 2 equals x minus 1. I don't need parentheses anymore. So plus 1, and x equals 3. So what does it represent? And we can just kind of even take this and fill in what we copy and paste. So when we sell cans for $3, we will sell, well, y was 0. I'm not going to sell any. I'm going to sell 0 cans. So no one's going to buy any. Alrighty. So we talked about when the price is 0, how many cans will I sell? And then we just talked about at what price will no one want to buy anymore. And that's the x-intercept when our output is 0. Okay. I think that's all for that example. It's a pretty cool example, I think, like figuring out what the x-intercept and the y-intercept mean in terms of the problem. And I think this is also similar to a homework problem that you guys will have. All right, so vertical and horizontal lines. Oh God, that was gross. I'm so sorry. Oh God, okay. So sorry, I'm so sick. If this is grossing out, I'm so sorry. Okay. So I think, oh, that's it. Okay, no. So a vertical line that passes through AB, so the point AB, its equation is going to be, so it's a vertical line, it's going up and down. That equation is going to be x equals a. All right. And then for a horizontal line, that equation is going to be y equals b, right? So if it's going to be, it has to match that x value. It's going to be every x value that goes like that. The y value never changes, so it doesn't matter which one that is. It's just going to be those x values. Similar for a horizontal line, it's going to be y equals b because we go like that, we go that way. Oh, 1 second, I need to pull something up. Let me pause real quick. Sorry. Okay, I'm back. I needed to pull up some extra notes and it was taking a little bit of time. So let's talk about vertical lines really quickly. You guys can still see. Okay, good. Just like have nightmares from that one time that it like wasn't working and I had to like re-record. So let's first look at vertical lines. So this point right here, right, that's my x-intercept, right? This is my x-axis, this is my y-axis. So this would be like a0, right? My x-intercept happens when y equals 0. We've talked about that. So then it's a vertical line through this point. Whee. So on and also down and so on, right? So every point is going to be a something, right? It doesn't matter. It's always going to be there. And there's no change in the x value, only changing in the y. So the way that I like to remember it is because, well, x equals a. We usually know if we talk about horizontal lines, let me paste this over here, that we talk about like y equals mx plus b, and m is our slope. Well, this one is this horizontal line. What's the slope of that line? It's 0. The y's are always going to be the same. The slope is going to be like b minus b over something. It doesn't matter, which is always going to be 0 over something, which is 0. So the slope is always 0, which is a flat line, and I can walk on a flat line, right? The floor that you walk on has slope 0. Do not bark. Mailman's coming. So stop. So if the slope equals 0, then we just have y equals 0x plus b, which just equals b. And that's how we get y equals b. Knowing how the horizontal line works kind of then just fills in the rest for x equals a for the vertical line. Well, I can't have a slope here. I can't walk up the wall. I'm not Spider-Man. So I can't walk up this little line. It's not going to happen. If I wanted to go find the slope, this would be like m equals b minus 0 over a minus a. And I would just get b over 0. And I can't divide by 0. This is what we would call undefined. So I can't have a y equals mx plus b situation where m is defined. So a vertical line, this is also where the vertical line test, right? It comes in with all the x's being the same. So if that function hits it, it means 2 x values have 2 outputs, blah, blah, blah. So it doesn't have a defined slope because I can't divide by 0. So what's happening is I can't say y equals something. I can only express it in x equals because of that. And I hope that makes sense. Okay. So if it's a flat line I can walk on, it's going to have a slope. If it's a wall, can't walk on it. So that's the only case where I'm going to have an x equals a number. Okay. And that's the vertical line. And questions that I can ask you is like, what's the vertical line that goes through this point or that intersects this line? Blah, blah, blah at this point. Sorry about all of the annoying noises. All right, cool. So when is the graph of an equation? When is the graph of an equation of a line? That doesn't make any sense. So we've seen many different equations to write a line, right? We can write them into what is also called the general form of the equation. I need to make this long enough of a line. All right, so the general form is my least favorite one. Okay, so the general form is ax plus by plus c equals 0. But where not a and b are both 0, because then if they were both 0, then c would equal 0, and then you might have some contradictions. The useful thing about general form is I can also express horizontal and vertical lines in this form. I can't express vertical lines in slope-intercept form or point-slope form because it doesn't have a defined slope. So general form comes in and he's like, I got y'all. Just put everything on the one side, make it equal to 0, call it general form. Okay, so this is the third form that you'll need to know. So for the for a linear equation, 2x minus 3y minus 12 equals 0, we're asked to find the slope of the line. So many different ways to do this. You can just plug in 2 values for y and then find the slope between them. I think that's a lot of work, but we can just take the general form and change it into slope intercept. Kind of hard to do slope point just because it could get a little weird. Intercept, since you don't know what to pull out. Intercept form. Okay, that's an F. So 2x minus 3y minus 12 equals 0. So let me just boot 3y over. So I get 2x minus 12 equals 3y. And then I'm divide each side by 3. 3. So I would get y equals 2/3 x minus 12 divided by 3 is 4. Remember, this is why I told you that that wasn't the appropriate form when it was like something times x minus something over something else, because it doesn't explicitly tell you what the slope is. So that's why instead of writing like y equals 2x minus 12 over 3, we're writing it like this, because it'll just tell me that my slope is 2 over 3, just like that. Okay, now we're asked to find the x and the y intercepts. So x-intercept, that's when y equals 0. So let's just plug it back into the general form if we want to, right? So I have to get 2x minus 3 times 0 minus 12 equals 0. So I get 2x minus 12 equals 0. 2x equals 12. X would equal 6. I did that very fast. If you want to stop and do it yourself first, by all means. And then the y-intercept, I could also plug it in. It's when x equals, oh, no. Yeah, it's when x equals 0. And I know from slope-intercept form, I could also just plug it into here. It doesn't really matter. So y equals -4. You could have also plugged into the general form and done that. Both are absolutely perfect ways of doing it. Okay. I think that's all that we have. So we are done with 2.3. Ooh, Duke shook it off for you guys. So I hope you enjoyed that. Okay, cool. So next time, 2.4 is actually pretty fun. It's a little bit shorter. So I will see you guys there in a second.